Hello, everybody. Welcome to Dome to Home today. Let's give it just a second here.
Yeah, welcome everybody. When we're waiting for a couple people or some more guests to hop on to this live stream, just a couple of reminders. If you're having some trouble seeing some things, it usually helps if you go full screen on that YouTube video. Rami is our chat moderator today, so she'll be looking for questions and comments in that chat box, so feel free to ask away over there.
Excellent. So I think we've waited long enough. So glad you guys could join us today for Dome to Home. My name is Tara. I'm a planetary scientist and a CU alum and a presenter at Fiske Planetarium. And Jeremy is here with me as well. Hi, Jeremy.
Hi, Tara. Good to see you again, and good to see all of you guys virtually, of course, through YouTube. As a reminder, yes, this is our Dome to Home show. Everything that you see up here on the dome will be controlled live by me. Tara will be doing the presenting today. Oh yeah, a little bit about myself. When we're not doing these virtual shows, usually I work at Fiske as a presenter and outreach navigator. Other than that, I think we have a great show planned for you guys today. Excited to talk about water on Mars and the water in the rocks. So Tara, go ahead and take it away.
Yeah, it's going to be super fun. So again, if you have any questions throughout, go ahead and drop them in that chat, and Rami will pass those on over. I might ask you some questions as we're going along, and feel free to answer those in the chat as well. I'll try to answer some questions as we go along, but we have time scheduled at the end too. So if you want to hold on to them to the end of the presentation, that's okay too. But yeah, let's go ahead and get rolling. So again, we are here today to talk about the water on Mars. Water in the rocks, on the rocks, around the rocks. There's actually quite a bit of water on Mars. Maybe not how you think it might be, though. So first off, let's take a look at Mars from here out in space, which is what we kind of see here on our screen. If you look to the dome view there, you can see a little bit of Mars. It's mostly in shadow right now, but we can kind of move around so you can look at the planet a little bit better.
Yeah, we'll go ahead and enhance it a little bit so that way you're not dealing with those pesky sun shadows.
Yeah, shadows. So see, while we're looking around here, if you can see any evidence of water on Mars from out in space, like at a global view. Anything look familiar?
Maybe a couple things.
Maybe you see some little spots.
Looks like there's some weird little holes, some tracks.
Mm-hmm. What if we roll around to look at the North and South Pole? See what we can see here.
Oh, there's something coming up.
So when we look at the poles of Mars, we actually see a ton of ice. Mars has ice caps, just like we have here on the Earth at the North and South Pole. Except on Mars, it's much, much colder than it is here on the Earth. And so these ice caps have a lot of regular water ice, like we're familiar with, but also CO2 ice, carbon dioxide ice, which you may have heard of, called dry ice. Now, here on Earth, when we have dry ice, it's warm enough that that ice doesn't even melt. It just goes straight from solid to gas and disappears. Right? It makes all that cool fog. But on Mars, because it's so much colder, it can stay in that solid state. In fact, the polar temperatures on Mars can range from around -80 Fahrenheit all the way down to -200. So it is very, very cold on the poles of Mars. So that's why it keeps those ice caps. Now we can also look at Mars on this global scale and think more about water where it might have used to be. Now we don't see liquid water on the surface of Mars right now. But what if we look at the planet itself? Are there ways that we could maybe see where water might have used to been? Well, let's take a look at a topographic map of Mars, a map that shows us the high elevations and the low elevations and everything in between. So you can see the dark kind of blues and purples are where things are very low. The red areas and oranges and yellows are where things are very high, like mountain ranges and ridges. Now, if we look at the northern hemisphere of Mars, the northern half of the planet, we can see the whole northern hemisphere is very low and very flat. Now, why would that be? Do you have any ideas why that might be? Well, it's quite possible that Mars has this area, this flat, low area. We don't see a lot of craters. That might be because that could have been a liquid water ocean at some point. If we look at the oceans here on our Earth, they're all very low in elevation, very kind of flat. We don't see a lot of evidence of things like craters and things like that because the water can wash them away and erode them away. And so we see the same thing on Mars. The northern hemisphere of Mars is very flat and low. And so we think that there might have once been water there, which is pretty cool. Now we can look at kind of a representation of what we think Mars might have looked like with all of this water on it. Let's show them what we call wet Mars.
Alrighty, here we go.
Yeah, so you can see here, if we put water over those really low elevations, we can get a whole big ocean in the north. You can see as we kind of orbit around, there's continents and mountain ranges. You can also see things like lakes and rivers. So we don't know for sure. Put that out there. We're not positive, but we think this is kind of what Mars might have looked like billions and billions of years ago. This was a very long time ago, so definitely not any time recently.
Looks pretty familiar. Looks pretty similar to another planet I know of.
Yeah. Now, while we're on the subject, I see that Aurora had a question about what are the warmest temperatures that Mars has ever seen. That is an excellent question. Mars actually, in some situations, under just the right conditions, in just the right place on the planet, it can get above freezing. In fact, it's gotten up to almost 70 degrees on the surface of Mars before, which is pretty crazy. That's 70 degrees Fahrenheit, far above freezing. So there's probably instances where Mars could maybe possibly have a little bit of liquid water, which is pretty interesting. I also see Roger had a question about canals on Mars. Was there a man who looked through a telescope a long time ago and thought that Mars had canals? There absolutely was. There was the first guy, his name was Schiaparelli. He was the one who discovered what looked like lines on the surface of Mars. And he was an Italian, and he used the word canali, which is just kind of a general word for water flowing along the surface. But a British gentleman, Percival Lowell, looked at these maps like Jeremy's showing you here and saw that these were very straight lines, and he heard the word canali and he assumed canals, like beings had built this. And so for quite a while, he was pretty convinced that there were actually living things on Mars building canals and moving water. Now we know now that that's not true, but this was a long time ago, back in the very, very early 20th century. So, that's how science works sometimes. We have ideas and then sometimes they turn out to be wrong. But now we know more than we used to. Good questions, guys. So let's turn now. We've been looking kind of at this global scale Mars. Let's look closer down to the ground and see what kind of things we can see that are evidence for this water that might have been on Mars at one point. And as we're doing that, I want to show you first a couple of pictures of Earth. And we've got a little collage here that we can put up. These are pictures that are taken of the Earth. Maybe these are features that look familiar to you. What would you call these?
I'm gonna go with rivers.
They definitely kind of look like rivers. Yeah, these are all pictures taken from either satellites or the space station. There's the Mississippi River, the Yangtze River in China, and the Nile. So those are all big rivers like this. Now, I also want to show you a couple more pictures of Earth so we can look at some other large water features. Maybe some of these look a little familiar too. On the bottom, we have a couple of river deltas. There's the Mississippi there on the right. And then above that, we have some other similar features. They're called alluvial fans, which is just where rivers have dumped a whole bunch of dirt and rocks and sediment out just right there. The two on the top are actually from Death Valley, which very rarely has water flowing on it, but just enough to make these fans. Now, I wanted to show you these pictures of Earth first, because now let's look at some pictures of some features that we've seen on the surface of Mars. Do we see some similarities?
Oh, yeah.
I certainly think so. Especially that one, like right on the very bottom, looks very much like those river deltas that we were looking at. It reminds me of my family's home around Houston. And then even to the right, we've got that very obvious kind of river channel. It's very snaky and wiggly. And even some of those alluvial fan kind of shapes towards the top and then on the left. This is one of the ways that we think that Mars had water on it, because we see features like this. And these features on Earth are specifically associated with having water on the surface, which is pretty cool. Now, we're also here especially talking about Perseverance, this new rover that's going to Mars. And one of the things that Perseverance is doing is it's specifically going to land in a crater that we think used to be a lake. It used to be a lake bed. It has this sort of riverbed deposits on it. We can show you a picture of the landing site for Perseverance. Jeremy's scrolling around there.
There we go. Yeah, so here's the kind of the from space image that we've taken of that landing site.
And you can see it's got a lot of those same features. You see that sort of delta fan shape down at the bottom. You can, if you look to the left, you see the river channel coming out. And so it looks like the river came down and then dumped all of its sediments out there into this lake, which is a big crater. So that's pretty cool. That's where Perseverance is going to land. And it's going to look for these evidences of water while it's there. Now, one of the things that Perseverance can look for is not just liquid water or ice, which is probably not going to be found in this particular area. But there's other evidences for water that we can look for, particularly minerals. There are certain minerals that only form in the presence of water. And these are things that you might have heard of before. I would hope you have heard of a couple of these, things like salt, or things like chalk, which is also called gypsum. These are minerals that form basically out of water and some other chemicals that mix together. In fact, with water, with salt, you can do this on your own. If you make a glass of really salty water and then leave it out in the sun for a couple days, eventually that water is going to evaporate and leave salt behind. And that's exactly what we think happened in a lot of these areas on Mars. They used to be covered in salt water. Well, then the water left, it evaporated away and left behind these salt deposits. So if we can find these deposits of things like salt and gypsum, that we can pretty reasonably say that there was probably water on the surface at this time. Now, first we saw this in things like meteorites. We found Martian meteorites that have hit the surface. There's a really great one called the Allen Hill meteorite. And we found these same sorts of salts and gypsums and things like that inside this meteorite. Now, we can also see these from space. We can identify these salt deposits on the surface. Here's this picture that Jeremy just put up. The blue area there, that whole big long streak, and then the kind of little puddle up at the top, those are all really salty areas. So we think that these probably had water on them, and the water evaporated away. Now, Perseverance also has some special instruments that are going to be able to analyze these samples that it's picking up. In fact, Jeremy has been looking into this. Why don't you tell us a little bit about the Perseverance rover, Jeremy?
Yeah, so let me switch on over to a view that you guys can see a little bit better here. So the first thing that is important to know about Perseverance is it's going to have this robotic arm that you can see in this circle here. And so what's key about this arm is that it has a pretty similar functionality to a human arm. So it has like an elbow joint. It's got kind of like almost like a wrist on it. And on this arm, towards the right side, you can see there's kind of like a little sharp drill looking thing. And so what Perseverance is going to do is it's going to land, it's going to go kind of rove around on the surface, and using its camera, scientists will be looking at specific rocks that look like they've been formed under processes that involve water, so maybe like a river flowing by. And they're also going to look for rocks that they think there would be a good chance that there would be could preserve microbial life kind of in the inner regions of that rock. So then what it's going to do is going to drill into that rock and then move its kind of robotic arm back to this section right in here in that little blue circle, which is a little sample holder basically. And so it'll put the little sample of the rock in this little pre-cleaned tube, and it'll store it there, and then it'll kind of put the sample on its back and then keep roving around, and then hopefully save that sample, and it's going to put it in like a depot cache. So basically just store it for later, for hopefully when humans hopefully get to Mars, they can then go find these caches and then do further analysis on these rocks.
That's pretty cool and super exciting. So I see that, let's see, we had a question from Mr. McFarland about tides on Mars. If it had these big oceans, would its moons affect the tides? And Rami gave a perfect answer here. I just wanted to restate it to make sure everybody saw and heard that. Yeah, Mars has 2 moons, but they're actually really, really tiny. So even compared to the size of Mars, which is only about half the size of the Earth, these moons are very, very small. They're actually more like mid-sized asteroids than moons like we think of. So because they're so small, they don't have a lot of gravity, and so they probably didn't have much effect on tides in Mars's ocean. That being said, if they ever both lined up in just the right way, it might give a little bit of a tug, but probably not like what we see here on Earth. Great question, though. I like that. So now we want to talk a little bit about where we might find actual liquid water on Mars. Now, there's one theory that we have thought of that has to do with these ice caps at the North and South Pole. Now, you probably saw a second ago, these ice caps are really big. They have a lot of ice, and they're very similar to the ice caps here on Earth, especially in Antarctica, because the Antarctic ice cap is actually sitting on rock. Up in the Arctic, in the northern hemisphere, the North Pole, that's all water or ice that's floating on water. It doesn't have rock underneath, but Antarctica does. And in Antarctica, we have these things called subglacial lakes. These are lakes that form underneath the ice, between the ice and the ground, like you see here. This is a picture of one called Lake Vostok. It's a really, really, really big lake underneath a glacier. I think it's the 16th biggest lake on the planet Earth, which is pretty cool. But you see it's very, very far down, 2 miles down underneath a bunch of ice. But because we see these here on Earth, we think that these could also exist under Mars's ice caps, especially the big, big, big one at the North Pole. In fact, there are some people, we just found out a couple of days ago, that they think they might have found lakes underneath the ice at the pole of Mars. Now, this just came out a couple days ago. It's very preliminary, so we don't know for sure, but they can use radar to look through that ice and maybe see some water down underneath, which is really cool. So keep your eye on the news for that. That might be coming out in the next little week or so. Now, we also see more of this ice on the surface of Mars, not just at the caps, but sometimes we see them in craters, which really excites me. That's something I'm stoked about. We can see that this ice can kind of collect in these areas, these craters. Now, sometimes it's already on the surface. This can happen with the ice actually being put up into the atmosphere and then coming down as things like snow. You do sometimes see snow on Mars, and it can collect in these craters, like this big giant one here, or the one you see behind Jeremy in Jeremy's background. He's got a cool icy crater there. Sometimes these craters can even dig up ice that's underneath the ground. We think that most of the ice on Mars is probably under the ground, but it may not be very far down. So occasionally we see craters that just after the impact have a bunch of ice either in them or around them. And eventually, if it's in a warm area, that ice will disappear. It'll evaporate away. Again, because it's so cold, it doesn't even, go straight into a liquid. It just evaporates out into space. So I think we have some cool pictures of those too that we can show you. This is a good one. One of our spacecraft flew over this crater on one day in 2008 and saw all this ice in and around the crater. And then less than a year later, we went back and looked at that crater again, and we don't see that ice anymore. That's how we figured it was probably ice around that crater, which is pretty cool. Craters are neat. There's another good one. Yeah. So there was a meteorite that hit the surface and dug up a whole bunch of ice, and it's all scattered around. Pretty cool. Now you may be asking, why do we care? Why do we care about water on Mars? What difference does it make if Mars has water or not? You may also know that water is very important for life, at least life as we know it. Now you may have joined us for the habitability talk that we did last week. So water, pretty much every part of your body needs water to function, and that goes for a lot of living creatures here on Earth. So we think that by looking for places that have liquid water, those are really good indicators of places that we might look for life. It's also super important if we want to think about sending humans to Mars to live on the surface. We would need water for drinking, for growing crops, but also for things like rocket fuel. So water is one of the most important things that we look at when we're trying to figure out if we can go to a planet and maybe stay for a while. And with that, we are right at the end of our time. We have hit our 20 minutes, but again, we do still have time to answer some questions. If you had any that you didn't put up in the chat just yet, if you were hanging on to them, go ahead and drop those in now, or if you think of any. Let's see what you have to say here.
Yeah, feel free to ask away, everybody.
Water in the solar system is one of my favorite things to talk about, so I am super excited to answer questions about that.
What's your favorite place to be searching for water, or where do you think, what's the one location in the solar system that gets you most excited when you think about water?
Ooh, when talking about water, I like the very far outer solar system, places like moons around Jupiter and Saturn. So they have, there's two moons out there, one of Saturn called Enceladus, and Jupiter has one called Europa. Now, these are both what we call water worlds, because the outside is a really thick layer of ice, but underneath that ice is a ton of water. In fact, we think there's not even like land underneath the water for a very long way. It's hundreds of kilometers worth of water underneath all that ice. That's a ton of water. And like for Europa especially, we know that it's salt water, just like here on Earth. And we know that there's tons and tons of living things in the oceans on Earth. So that's a really exciting place to think about looking for life elsewhere in the solar system too. Ooh, we have a great question here from Aurora. If there's currently water on Mars, what's to stop life from forming? That is an excellent question. So if there's liquid water on Mars, it's, like we said, it's probably underground. So that's going to stop a lot of things from living in it. Things that you may need sunlight, for instance. If it's really far underground, it's not going to have a lot of sunlight to access. So it would have to be something that can live without light. So probably no plants, probably not a lot of animals like we traditionally think of. That still leaves it open for things like microbes or tardigrades or other little tiny critters that don't necessarily need light to live. Now, you did mention the cold temperatures. That's another thing. It is very cold on Mars. And so there's not, as far as we know, we haven't found a lot of liquid water. So there could be big chunks of it, but there also could be a lot just kind of in what we call the pore space of the rocks. Think of something like an aquifer, where it's not necessarily like an underground lake, but there's just a lot of water in little tiny cracks and holes in the rocks. And so you would have to be very small, like the little tardigrades that Jeremy's showing here. You'd have to be really tiny to fit in those little pore spaces. And so it's not to say that life wouldn't be there, but it would make it a lot harder for us to find. You also have issues with things like the atmosphere. The atmosphere of Mars is almost completely carbon dioxide, which is bad for things that breathe oxygen, like us and most of the animals here on Earth. So that's one of the things. There's a lot of reasons why there could be life on Mars. it's just really difficult for us to find in a lot of these cases. It's hard to get to that water. Once we get there, you have to do a lot of processing and stuff to look for these tiny, tiny, tiny critters. So, and Mars is a whole planet, and we've only explored a very small portion of it. So there could be tons of life and water in places that we just haven't been to yet. That's one of the things that makes Mars really interesting to study and why we're so excited about this Perseverance rover. That's a great question, Aurora. Let's see, one from Roger. Do you think ESA's announcement about subsurface lakes will change Perseverance mission plan? Ooh, good question. Probably not at this point, because let's see, the lakes that they're talking about are very close to the poles, and Perseverance isn't going quite that close. Its landing site is a little further away, further than it could drive to. And with things like spacecraft missions and things like this, these are things that they've been planning for decades, years and years and years and years. So it's unlikely that they would drop all of these scientific goals that they already had in place to go and check this out. Now, that's not to say that they couldn't add it to something like an extended mission. Sometimes when we put these rovers on the surface, they'll go around and they'll accomplish all of their scientific goals and they'll still be good to go. They could still have life and battery and everything. So maybe at that point, they could turn around and try to traverse some of the terrain and get to a place that's maybe not these actual lakes, but similar places, something like that. So probably not going to happen right away, but it's definitely something I'm sure that the science team is definitely looking at for sure. Let's see, another one from Mr. McFarlane. What factors could affect winds and air currents on Mars, like big dust storms? Is the evaporative process of uncovered water involved? That is an excellent question, and that is actually a very active area of research right now. I know several people who look at the polar regions of Mars and how winds and evaporation and snowfall all affect these things. Atmospheres are super complicated here on Earth, and even a really thin, simple atmosphere like on Mars. Everything works together, just like our atmosphere here on Earth. So it's affected by things like temperature. It's affected by the sublimation of that CO2 ice when it gets warm in the summer. Once those dust storms kick up, they can cover the whole planet and then dump a bunch of dust down on top of those ice caps, which can change their albedo, how bright they are, how much sunlight they reflect, which can affect the temperature of the planet, and so on and so on and so on. It's a big domino effect. So there's a ton of stuff that ends up being involved in this atmospheric research on Mars. We have a spacecraft out there right now called MAVEN that's actually run from CU that's specifically studying Mars's atmosphere. You may have also heard of a new one called HOPE. This is launched by the United Arab Emirates back over the summer. It's another one that's going to study Mars's atmosphere specifically. So these are two really great spacecraft that are really getting into study the nitty-gritty of Mars's atmosphere. Perseverance is going to do a little bit of that too. It's got some sensors so it can measure things at the ground level. Oh, excellent questions. Let's see. Anyone else? We've got like 2 minutes left. If you've got a burning question you want to throw in. I know Jeremy has done a little bit of study with Mars's atmosphere. He worked a little bit on that MAVEN spacecraft.
Yeah, a little bit. Not so much dealing with the water in the rocks or anything like that, but when you look at MAVEN, we see kind of the atmosphere being stripped away by the solar wind. And, you know, one of the questions is, well, if this is a major loss process of the atmosphere of Mars. And so what my research was doing is there's a couple different kind of main channels that the atmosphere is being stripped away from Mars. And in particular, I focused on just one of those channels, trying to figure out kind of the morphology of it. So how it was shaped and why we think it was shaped the way it is. And if you guys want to know a lot more about MAVEN and what it does in the atmosphere of Mars, we have an entire episode dedicated straight to that. We'll actually have some guest scientists who work on the MAVEN team, and who have worked on the MAVEN team in the past. That one's coming up third week in October. So if you guys want to really dive deep into the atmosphere of Mars, definitely come back for that one. October 21st, I believe.
Excellent. All right, we've got time for this one last question, which I think is a great question. If there's life on Mars, why aren't they trying to find us? That is the $1 million question for pretty much any life in the universe. We always ask that. And with Mars in particular, we're pretty sure that if there is life on the surface, it's not going to be like people or even really animals or plants or any of these large creatures. We think it's probably going to be something like microscopic life, like bacterias or, little critters that swim in the water, or again, those tardigrades. Yeah, things like this. Little single-celled organisms and things like that. Which I can't say that they wouldn't try to contact us. I don't know how developed these single-celled organisms might be. There's absolutely a chance. But probably they're not sending out a lot of radio signals or building spaceships or anything like that. Can't say for sure. We don't know. But this is more of the kind of life that we're talking about when we're looking especially at Mars. Probably going to be little bacterias and things like that. So they're probably not reaching out, but they might be. You never know.
You never know. That's science, right? You don't know until you know. And then even when you know, things might change down the road. So
that is absolutely true. Well, on that note, we are out of time now, but thank you all so much for joining us today. If you do have any other questions, go ahead and drop them as a comment on the video here. We'll try to get back to you, or you can send us an email through our Fiske website, colorado.edu/Fiske. Got all sorts of cool information there, including you can access our past videos, upcoming videos, and be sure to join us again next week, where actually our friend Rainey is going to be telling us all about Perseverance, the mission, and how we designed it and how we put it together and what the history of the actual mission is. So if you're interested in mission science, definitely come back next week. And until then, have a wonderful week. We'll talk to you soon.
Bye, everybody.